So we have here a speaker that actually did Java for a long time and now is doing the right technology. Who knows what is the right technology? Who has ever done C#? Okay, this is what I meant. Give it up for Mete.
All right, thank you. All right, let's just wait for people to come in, and then I'll start in like 1 minute. Come on, people, we are starting. Let's go. All right, I will start gradually. All right, let me start my timer. Cool. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. And this is my first time in Belgrade, and first time in Serbia, and first time in Balkans, actually. So I'm really excited to be here. For some reason, I've been all around Balkans, and I'm also originally from Cyprus, so I've been to the Eastern Mediterranean, but for some reason, I never made it here, so I'm very excited to be here. So I'm going to talk about microservices with Kubernetes. If you want the slides, my Twitter is up here, so you can just follow me on Twitter, and I'll post my slides after that. And if you have any questions about anything, I'm going to be around throughout the conference anyway, so just feel free to stop by. And then this is my email as well, so if you have any questions about Kubernetes, about Google Cloud, or anything like that, feel free to send me an email, OK? So before I start my talk, I'm curious. Who is running code in production today with containers, with any kind of container? OK, a few people, good. And who is using some kind of orchestration framework like Kubernetes or Mesos? A couple of people. So that's good, because this is about containers. So I will start with why we should care about containers a little bit so everyone is on the same page. And then I'm going to talk about container management platform, Kubernetes, and what it basically provides for your container as applications. And then we'll do a summary in the end. Anyone remembers these? Yes, OK. So I'm not the oldest guy in the crowd. That's good. So I actually started my programming career with this one. I didn't use the big one. And at the time, it was a hobby. I was like 10, 11 years old. I had a disk just like this. It was an MS-DOS operating system. So I would just put that into my computer, turn it on, and wait for the operating system to load. Once it loaded, I would get the A prompt, and then I'll take the disk out, put another disk, and I think it was GW Basic. Anyone did GW Basic here, or any kind of Basic? Yeah, that's how I started. And then I would just get into my development environment. And in GW Basic, you had to use line numbers. So I would just start with 10 and write my command, then 20, write my other command, and just do that. And all I had was this disk and a book on basic programming language that a friend of mine gave me. So that book was kind of like my Stack Overflow. So I would just look at the book, copy the code, and then just try to run it. And then I would try to change it to learn the language. So I learned some things on my own. But at some point, I remember I wanted to do I wanted to add some sound to my program, but there was nothing in the book about that. So I was stuck for like probably like a weekend trying to figure out how can I do sounds with this program. And once I figured it out, I was doing all sorts of sounds from the program, but that drove my mom crazy. But anyway, the reason why I mentioned this is that I really like the simplicity of those times, because all I had to worry about was this disk for my operating system, the disk for my development environment, and one book. There were no distractions, so I could just focus on my problem and how to code the problem. So I really like those times. And then a lot of things happened since then, obviously. The first thing is, and the most important thing, is the internet. And after the internet, we had an explosion of other things like microservices, cloud computing, web service, machine learning, IoT. So the world is not as simple, and it's impossible to know everything nowadays. So what I try to do is I try to pick and choose some things that I'm interested in, such as cloud computing and microservices and containers. And then for the rest, I'm trying to get an idea of what's out there so I can at least know what the landscape is. But when you want to solve a problem today, you still start with the code. So let's just imagine this is the piece of code that I have to solve some kind of problem. This code doesn't live on a disk anymore. It usually lives on some kind of machine. So you deploy it to some kind of machine. This can be your machine, or maybe you're using a cloud provider, so maybe it's somewhere in the cloud. And your code is running, and that's great. But the problem you have at this point is that it's on a single machine. So what if this machine goes down? What do you do? So to avoid the problem, you replicate your code on multiple machines. This way, you have some kind of redundancy. But then you have another problem. How do people find your machines? Because they each have their own IPs, and how do people discover them, right? So what you usually do is you create a load balancer that has a stable IP, and then people will hit the load balancer, and then the load balancer will use some kind of algorithm to load balance between these machines. That's good, so we have some kind of redundancy in it right now. But how do you even know that your application is healthy, right? Just because your computer is running doesn't mean that your application is healthy. So what you do in that case is that you usually create what's called a health endpoint. And the job of this health point is to check what it means for your application to be healthy, and then report whether it's healthy or not. But of course, someone has to check this health endpoint, otherwise it's pointless. The load balancer can check this health endpoint, or you might have some separate health checker that will ping these health endpoints once in a while and make sure that your application is running. And if not, maybe take an action. So if one of the machines goes down, maybe it will recreate a new machine and deploy your code there again. So this is good. We have resiliency, we have redundancy. But the problem is this lives in a single zone right now. So it's in zone A. And even with big cloud providers, sometimes the whole zone goes down. So if your application needs to be up and running 24/7, you obviously cannot rely on a single zone. So what you do is you replicate everything on a different zone. So you do the same thing with the machines and the load balancer and health checker on a separate zone so that you have some kind of redundancy in case the first zone goes down, right? But now you have another problem. How do you keep track of the state between two different zones? Because there's some state on zone A, and you want the same state to be on zone B in case you need to fail over, right? So in a very simplistic way, you can basically create what's called a task queue. So every time there's some kind of state in zone A, you can write that state in your zone, and then you can also send a message to this queue. And then someone from zone B will pick that message and apply the same state to zone B. This way, the two zones are in sync. That's great, and your application is resilient and redundant. That's great. But what if your application is successful and you want to scale out? You want to add more machines. Of course, you can add more machines manually if you want to. But usually, you don't want to just add machines. You want to add machines when there's load, and you want to take them away when there's no load. Because most of the times, the load is cyclic. So you have more people using it during the day, and then at night, you have fewer people using your service. So you want to scale down so that you save money. So what you do in that case is that you either create one or you use one, something called Autoscaler, that will look at the metrics of your application, whatever those metrics are for your application. And depending on those metrics, it will determine whether it needs to scale up or scale down. Okay? This is great. So I have resiliency, redundancy, auto-scaling, replication. Everything is working great. But we just started with this piece of code, right? Like, I mean, that's the piece of code that's actually solving the problem that we want to solve. But this is what we are basically we have to maintain today, right? And this is not optional. Like, I mean, you can't just say, oh, this is the code I write, and someone else does all this work. We used to do that before, right? We used to just write the code and give it to operations people and say, just run this code, I don't care. But nowadays, we don't do that because we have DevOps, and we are responsible for our code end to end. So these things are not optional because people expect our application to run 24/7. But at the same time, it's taking time away from our real problems. The code is what's solving my real problem, not the other things, right? So what do? If I have to imagine how software development should be, I think there are some pillars that I want to be true at this point in time. The first thing is I want to be able to write code in any language, and I want to make sure that that code runs exactly the same way everywhere. We should have this today. We shouldn't worry about whether this code runs on Linux or whether it runs on Windows or whether I need this kind of compiler or that kind of compiler. We had these problems before, but at this point in time, we shouldn't have to worry about this. Second thing is my app should be optimally deployed and managed. So I write the code, I solve the problem, and once I deploy it, it should be optimally deployed in my environment, and it should be managed by someone. And I shouldn't have to worry about that myself every day. Like, that should be automatic. And the third thing is all the resources that I need for my application, they should be provisioned on demand. So if I need more machines, I should get them on demand. If I don't need them, they should go away. I shouldn't have to worry about capacity planning. I shouldn't have to worry about filling forms to order more machines. Everything should be ready for me when I need them on demand. And if you look at what's happening in the last few years in technology, I think we are heading in the right direction. So writing your code in any language and running it anywhere exactly the same way. Well, that's what containers are all about. So Docker, Rocket, these are container platforms, and they're all trying to do the same thing. They're all trying to give you that context where your application runs exactly the same way. When you look at your app is optimally deployed and managed, that's what container management platforms, orchestrators are all about. So Kubernetes, Docker Swarm, Mesos, they're all trying to do this kind of stuff. And all resources are being provisioned on demand. That's what, for me, that's what cloud is all about. So Google Cloud, AWS, Azure, they're all trying to give you a framework where you can get resources on demand when you need them, right? So I think there's still hope that we can get back to the simplicity of old days because we have the tools today to get there. So let's just talk through containers first, why they matter, and then after that we're going to talk about Kubernetes, and then we'll wrap it up after that. So containers. So first of all, why containers? Why should we even bother about containers? We already have enough stuff to worry about. Like, do we have to know about containers? And the answer is, unfortunately, yes. There's always new things to learn. And containers, at first, they might look weird and kind of quirky, but they really simplify things. And here's why. If you look at how we used to deploy applications, this is how it looked like. You had a physical machine. On top of that, you had the operating system kernel. Then on top of that, you had the libraries that your application needed. And then you would deploy your applications on top of these common libraries. Now, this was a simple model, one machine, one set of libraries, one operating system, but there was no isolation between your applications whatsoever. So every time you had to change something with your operating system or libraries, you could potentially break all your applications. So even though this was simple, it wasn't really a good model. Then came along virtual machines. So the idea of virtual machines, as most of you know, is that on a single physical machine, you can have multiple operating systems virtualized. So in these virtual machines, you have the operating system, you have the libraries, and you have the application. So there's total isolation between applications, which is great. But at the same time, now we have to deal with 4 operating systems instead of 1. And these virtual machines, they're not lightweight. They're gigabytes in size, so they're not so easy to create. They're not so easy to move around. So most of the time, people use virtual machines at deployment time, but they wouldn't use them in their development time. So you would just basically write your code without virtual machines, and then when it's time to deploy, you would deploy them using virtual machines. So there was still a disconnect between development time and deployment time. So containers, they're trying to combine the best of both worlds. In containers, you have a single machine, single operating system, but you're virtualizing from libraries up. So you're virtualizing your application and the dependencies of your application in what's called a container. So in this model, the containers are really small compared to virtual machines. They're megabytes in size rather than gigabytes. So they're really easy to create, they're really easy to run, and they're really easy to move around. But they also provide the isolation that you need in your applications. So you get the best of both worlds with containers. So what is a container? Basically, in a nutshell, a container is just a lightweight way of virtualizing your applications. As I mentioned, they're sealed and isolated, so you can have multiple containers, tens of containers on a single machine. But they don't interfere with each other. They're very easy to deploy. Within seconds, you can deploy them. They're introspectable, so you can actually get into the container, look at what's happening as if it's a virtual machine. And for me, the most important part is they're composable. So what you can do is you can basically have a base image that your application needs. So that's your dependency. And then you can build your image on top of it. And then if someone else needs your image, they can build their image on top of yours. So all the dependencies are layered. And these layers are cached, so if you have 2 containers that depend on the same base image, and if you already have the image, then you don't have to download it again, so it gives you all those benefits. Docker is the most popular container platform, but there are others as well. There's something called Rocket from CoreOS, and I'm sure there will be more going forward. And then Docker, so Docker basically made containers accessible to software developers. Containers and the technology behind containers, they've been around for a long time. And actually, at Google, we've been using containers for more than 10 years. But Docker made them accessible to everyday software developers. For me, the most important thing in Docker is the Docker file. So you basically define your environment in a Docker file. So in Docker file, for example, in this case, we are defining our dependency. This is the image that we are depending on. So that's our dependency. Then we define our environment. So what happens, what kind of environment my application needs. So I need some packages, and I also need the port. And then you define what happens when the container starts. So this is the command that runs when the container starts. So in a single file, you define your dependencies, your environment, and what happens when your container starts. And then Docker makes sure that your container runs exactly the same way everywhere Docker is. So that's the beauty of Docker. All right, so now what I want to do is I want to basically start with a really simple application and just show you how it works. And then after that, we want to containerize it using Docker and see what the process looks like. Once this application is containerized, I want to push the image to Google Cloud, and then I want to create a Kubernetes cluster and then let Kubernetes manage this application. And then throughout this journey, we'll learn what makes Kubernetes great. Okay? So the application that I want to show you, it's an ASP.NET Core application. So it's an ASP.NET that runs on Linux. And it's just a simple Hello World application. So this is Google Cloud Management Console. In Google Cloud, there's something called Cloud Shell. It's basically a shell that you get in the browser. And from this shell, you can do whatever you want. So here, I got my shell, and I have my space. And I already have the tools that I need within this shell. One of those tools is called .NET. So .NET is a command line tool that you can use to create .NET Core applications. So it's already installed in Cloud Shell. So what I'm going to do is I'm going to create a folder for my application. Then I'm going to use the .NET command line tool to create my Hello World application. And I'm just going to run it quickly and then see that it works, and then we'll containerize it. So I'm creating my folder now. I'm going to call my application Hello World ASP.NET Core. And then I'm in the folder, and I'll just say .NET new-t web. So this creates a Hello World web application in .NET. And then if you look at the files, you see the bunch of files I created for me. Program.js is the main file, the entry point to my application. I will just edit the file and add a single line to make sure that this program starts on port 8080. Because by default, in .NET Core, application starts on port 5000, and I don't want that, because I want to be able to test this application from the browser. So for that, I'm going to use port 8080. So I'm just adding one line, use URLs, and then star 8080. This way, my app will bind to port 8080. So we did that, and then I'm going to do .NET restore. This will look at the dependencies on my application, and it will download them from NuGet. NuGet is a dependency management tool in .NET World. So now it's looking at project.json, and then from there, it will download all the dependencies. So this will take a couple of seconds. So once this happens, we'll do .NET Run and just test our application, make sure that it works. So it's very simple, and it's simple for a purpose because this app is not the point of my talk. Kubernetes is the point of my talk, so I'm just going to use this app as a showcase for that. So we'll do .NET Run. Now this will compile the application, and then it will just run it quickly here. And one of the nice features of Cloud Shell is web preview. So you can just basically from the browser go to web preview, and it will connect to the Linux box where this app is running, and it will display it in my browser. So that this way I can test it really easily. So now we are connecting to the Linux box, and then there you go. This is the Hello World simple application. Nothing exciting, but it will get more exciting, I promise. So now let's containerize this application and see how that looks like. So here I am in the folder again. The first thing I need to do is I need to create a single executable that Docker can use to run. So for that, I'm going to do .NET publish-c release. This will compile my application, and it will compile all of its dependencies into a single DLL. And then I'm going to use this DLL from Docker. So Docker will call this DLL. If you're a Java person, this would be similar to creating a jar file, basically. You create a jar file so you can run it. And in other languages, I'm sure there's similar things. So basically, I'm compiling everything into a single file. And then next step will be to create a Docker file. So I want to define my environment for my container. So we'll go through that, and I'll take a look at that quickly, because Docker file is really important. So I want to show you that quickly. So we are compiling it now. And then once it's done, I'm just going to copy the Docker file that I have into the publish folder, and then we'll take a look at the Docker file from there. All right, so it's compiled, and then I'll just go to the publish folder where my DLL is. And then I have a bunch of DLLs, but there's one that I care about, and I'm just going to copy the Docker file now, and we'll just take a look at that quickly. All right, so let's just take a look and pause here for a second. All right, so if you look at it here, the first line says, from Microsoft.NET 101 runtime. So this is a .NET application, and I need a .NET runtime. So I'm basing my application on an image given by Microsoft. So that's the base image that I depend on. The second line says copy dot to app. So it copies this folder, the contents of this folder, to the app folder in the container. So this will copy my DLL that I need, basically. Then I'm setting the work directory to app in the container. So that's where the things will start in the container. Then I'm setting my environment. So I'm exposing port 8080. And then I'm also setting an environment variable called ASP.NET Core URL. So this will make sure that my application starts on port 8080 as well. So I'm exposing port 8080, and I'm making sure that my .NET application starts on port 8080. And then finally, entry point. What happens when the container starts? I'm calling the .NET runtime, .NET command line tool, and I'm pointing to my DLL, right? So with this one file, again, like I explained before, I am defining my dependency, my environment, and my runtime, what happens when it runs. So once we have this, we need to create an image. So to do that, we'll use Docker command line tool. We already have Docker installed here in Clash Shell by default, so I don't have to install it. But I'll say Docker build, and I'll tag my image with -t. And I'm going to use a special syntax for that. I'm going to say gcr.io. This is Google Container Registry. I do that because I want to push this image to Google Container Registry later, so that's why I'm tagging it this way. And I'm just saying .NET Atamel is my project name, hello.NET is the name of my image, and I'm also giving it a version name, version 1. And now this will look at the Docker file, and it will execute the steps that I outlined, right? The first step is to get my dependency. My dependency is not on my machine, so it will go to Docker Hub, and it will download the dependency on this machine. And once we have the dependency, we'll go through the other steps and set our environment. So we'll just wait for that for a couple of seconds. This is usually like fast if you already cached it, but it's not cached here, so that's why it's taking a little bit of time to download. So once this is done, we're going to do the steps, copying our DLL, and exposing our ports, all that kind of stuff. So if I do Docker images, now I should see my image being built. And actually, I should see two images, my image and my dependency image, the image that I depend on. So if you do Docker images, you see the first one is my image, the second one is the Microsoft image that I depend on. And just to run this, make sure that it works, I'll just do Docker run. I'll pass in -d. -d means run in the background. And then -p means port. So I'm doing port mapping. So I'm going to map port 8080 on my machine to port 8080 in the container. And I'm just going to point to the image name that I just created. So this will run the same application, but this time the difference is it's in a Docker container instead of by itself. So it's running, and if I do Docker PS, I see that it's running. And if I do a web preview again, we're going to see the same application. So from outside, it looks the same, but it's running in a Docker container, OK? Cool, that's good. I think that's all I want to show here, except what I want to do right now is, once I have the image, I want to push it to Google Cloud. So to do that, I'll use gcloud. It's another command line tool that you can use to talk to Google Cloud. So I'll say gcloud docker push, and just point to my image. So what will happen is that this will basically take the image that I just created on my machine, and it will push it to Google Container Registry, right? So that's the beauty of Docker. Once you have the image, you can push it to different places, and then you can pull it from different places and use it in different places. And what we're going to do is we're going to use it from Kubernetes next, OK? We won't wait for this because we don't have time, but in the end of this, the image will be living in Google Container Registry. All right. So we containerize our app. That's great. And we are done, right? Like, we are done with containers. We containerize, everything should work. But it doesn't, actually. Containers are not enough. So if you want to have redundancy in your application, you need to run multiple containers. And you have to do that yourself. If you want to scale up your application, because your application is being used, you need to create more containers on your nodes, and you need to scale up. If you want to scale down because people are not using your application, you need to do that yourself. If you want to have resiliency, you need to create health endpoint, like I talked about, and check them. If you want to roll out a new version of your application, you need to do that yourself. So one by one, you need to update your containers to the new version. If there's something wrong with the new version, you need to roll back one by one, and you should do that. Configuration and secrets. So we always think about code as our application, but actually configuration and secrets are a big part of our application. You need to manage them, and you need to make sure that they are used. So all these problems that you have for running any kind of app in production, you still have those problems, right? Just because you took your application and containerized it doesn't mean that your problems go away. You still need to solve them. And that's why Kubernetes exists. Kubernetes is trying to solve this kind of problems, and it's trying to give you building blocks so that you can solve this kind of problems. So let's just take a look at what Kubernetes is. So Kubernetes is a Greek word. Actually, everyone says Kubernetes is wrong. In Greek, the right way of saying Kubernetes is Kubernetes, but Kubernetes, I guess it came from the US, and everyone started calling it Kubernetes, and even I call it Kubernetes, even though I'm from Cyprus and I know a little bit of Greek. But if you don't learn anything in this talk, just learn that the right way of saying Kubernetes is Kubernetes, OK? So it came from something called Borg. As I mentioned, at Google, we've been running containers for a long time, and we created an internal container management platform called Borg. So people who actually worked on Borg, they learned from it over the years, and they created Kubernetes for the open source world. It's 100% open source. It's written in Go. And for me, the most important thing about Kubernetes is that it supports multiple cloud providers. So you can run it on Google Cloud, you can run it on AWS, you can run it on Azure, you can even run it on-prem, so you can run it on your own machines as well. And the idea of Kubernetes is that once you create your cluster with the number of nodes, you think in terms of applications and containers, and you don't really think in terms of machines anymore, because machines are kind of abstracted away from you in the Kubernetes world. So at the very high level, this is what a Kubernetes cluster looks like. There's a master that manages the cluster, and then there are nodes. So these are actual machines, either virtual machines or your own machines, where the containers are scheduled. They talk through something called kubelets. But as a user, you don't really deal with nodes that much. You talk to the master either through API or CLI or user interface. And then you tell master, I want to schedule a container, and it will find the right place for your container in the nodes that it has. In this Kubernetes world, a microservice looks a little bit different. So you have your code in a container, and this code lives in some kind of registry. So this can be a Docker Hub registry, or it can be something like Google Container Registry. From there, you create something called a pod template. So I will explain what a pod is, but basically it's a way of running containers in Kubernetes. So you define a pod template, and then there's something called replication controller in Kubernetes. Replication controller, it's a way for you to tell Kubernetes what you want. In this case, we are saying we want to have 3 replicas. So replication controller will look at the template, and it will create 3 containers, 3 pods, and it will schedule them to nodes. So these nodes are the actual machines where the containers are scheduled. But replication controller will figure out where to schedule them. It's not your problem anymore. Once you have these pods, you can label them with different kinds of labels. And then you can group them into what's called a service. So a service is kind of like a load balancer for your pods. So you can group them in a service, and people from outside will call your service, and they will get to your pods through the service. So in this containerized world, your code and the combination of replication controller, pods, and services, so the things that Kubernetes provides, it becomes the microservice. So it's a combination of both, basically. So we'll go through each of these one by one. And I have to take a detour now. So as I mentioned, Kubernetes, it runs everywhere. But I'm going to show my demos on Google Container Engine. So I just want to explain you what Google Container Engine is so that it makes sense for you. So we'll do a detour of this, and then we'll come back to Kubernetes in 5 minutes. So Google Container Engine, it's basically Kubernetes as a service. We try to make it really easy for you to get a Kubernetes cluster, and we try to make it really easy for you to get logging and monitoring from your actual worker nodes. So we created Container Engine as a way for you to run Kubernetes in a really easy way. So to create a cluster in this world, in Google Container Engine, you just say gcloud container clusters create and give your cluster a name. So with this one command, you get a Kubernetes master, and you get some nodes to schedule containers. And it takes a minute or 2. So it's that simple. With this one command, you get everything you need to run a Kubernetes cluster. Then once you have your cluster, you need to do get credentials to authenticate your shell with the cluster. Once you're authenticated, you can use kubectl. kubectl is another command line tool to talk to Kubernetes. So you can say kubectl get nodes and see the nodes that you have in your cluster. You can see your pods, and you can resize as well. So you can, let's say you have 3 nodes, but you want to resize to 5 nodes. It's very easy in Container Engine. You will just say gcloud container clusters resize, and just say how many more nodes you want, size 5, and this will resize. This will add more nodes to your cluster. So what does Google manage for you in Container Engine? It manages the Kubernetes master. So master is you don't even have access to it. It's managed by Google. So you have backups, monitoring. You get auto-scaling with the nodes. You get auto-healing of the nodes. You get auto-updates if you want. So if there's a new version of Kubernetes that comes along, we will auto-update the whole cluster for you. And you get 99.5 SLA today. Today, there's only a single master, but we are also working to support multiple masters so that you get more SLA. And I think that's in early access right now, but pretty soon you will be able to have multiple masters as well. And then we also manage the actual nodes where the containers are scheduled. So you get logging, monitoring for free, and the runtime itself, the Kubernetes runtime, is also upgraded for you if you want to. And then last two things is the container registry. So we give you a private space to host your container images. Like I show you, you can create your image and push it to Google Cloud, and it will be saved for you in that private space. And then there's Container Builder. So you don't even have to build your container locally. You can use a build service that Google provides. And this build service it's really fast, and it has build triggers with GitHub and Bitbucket. And once you use Container Builder to build your image, you can this basically saves your image to the registry, and then from there you can deploy it to many places in Google Cloud, like App Engine, Container Engine, and Compute Engine. All right, so that's what Container Engine is. Now let's go back to Kubernetes and look at what it actually does for us. So let's talk about the Kubernetes building blocks. So when you look at Kubernetes technology, there's all this stuff, and there's even more. I didn't even put all of them. So initially, it can be a little bit overwhelming because there's a lot of terminology here. But the good thing is that you don't have to know everything up front. So if you know deployments and volumes and services, you're pretty much good to go, and you can learn the rest of the stuff as you need them. So I'll try to cover as much as I can with the time I have here. But if you have any questions about any of this stuff later, just find me after my talk, and I'll talk more about them. So everything in Kubernetes starts with a deployment. You can think of deployment as a way to get things started in Kubernetes. So with deployment, you just say, create a deployment with this image, and then that will create a pod, it will create a service, it will create a replica set, it will create all the other lower level things that you need, that Kubernetes needs, but everything starts with a deployment. There's this notion of pods in Kubernetes. So normally, you want to schedule a single container. But there are some use cases where you want to schedule multiple containers. For example, in this case, we have one container getting some files from somewhere, and it's saving to some kind of volume. And then this container, it's serving that stuff to some other consumers. So here, we have two containers and a volume with those containers. We can put them in a single pod. We can create a single pod, and then Kubernetes will schedule these as a single unit. So they will be scheduled as a unit, and they will be destroyed as a unit. And then, as I mentioned, volume is the pod scope storage. So that's where your pods can store some stuff, and they can attach to many different things. They can attach to persistent disk on Google Cloud, or AWS Block Store, or Azure File Storage, and many others. So once you have your pods, you can label them. You can say app equals my app. So this is your app's pods, or you can say phase like prod or test. You can say role is front end or back end. So you can label them in many different ways. And then you can group them using what's called selectors. So you can say, give me all the pods on my app using this selector. Or you can say, give me all the pods on my app with these roles, stuff like this. And selectors are really important in Kubernetes because that's how you create things. So when you create a service, you use a selector to group pods for that service. So you have your pods, you have your labels. Now you want to expose this pods to the outside world. You create what's called a service. So you create your service with the selector, type equals FE, and all the pods that have that type equals FE will be served by the service. Service will have a virtual IP, and then stable virtual IP, and then people will go through the service to your pods. All right, let me show you this really quickly. So creating a Kubernetes cluster, I'll skip that. But to create a deployment, so I push my image to Google Cloud, and I already have a cluster that I set up before. So I want to create a deployment. What do? You basically first, you run a kubectl command. But before I do that, I have to authenticate my shell with Kubernetes cluster. So I just run this gcloud command to authenticate. And once I do this, I can now run kubectl commands. So I will just say kubectl run hello.net. So that's the name of my deployment that I'm creating. And I'm pointing to an image. So this is the image that we created earlier and pushed to Google Cloud. And since it's already in Google Container Registry, I can easily point to it using this image equals. And I'm also going to specify what ports I want to be available in my cluster. And yeah, that's it. So now the deployment will be created. And if I do kubectl get deployment, we should see that it's already there. So it's really quick. And deployment creates other things under the covers, right? So it creates pods. If you look at the pods, you will see that it's container creating. So now it's trying to schedule the container to the nodes. But if I do get pods again, within a couple of seconds, we should see our container running. So it's very quick. And if you do get replica set, I'll talk about what replica sets are. But there's a replica set already watching my pod. And if I do kubectl get services, this is the load balancer for my application. It's already there, except it has an internal IP, but no external IP, because I haven't exposed it yet. And I'm going to do that next. So that's how you create a deployment. And to create a service, so I want to basically expose my service to the outside world. What I do is kubectl. So first, let's make sure that our pods are running. So they're running. But what I'm going to do is kubectl expose deployment and pass in my deployment ID. And then I'm going to specify what kind of service I want. The type, in this case, is a load balancer. So what this will do is it will create a load balancer in Google Cloud. And it will attach that to Kubernetes master. And then this load balancer, through the service, will get to the pods. So we do this. And then if you do kubectl get services, we see that there's an external IP that's pending, because load balancer is being created. And once it's there, it will have an external IP. I'll just fast forward this a little bit. At some point, we will see an external IP here. It takes usually like a couple of minutes. Yeah, we see an external IP. So now my load balancer is ready. And if we hit that URL, now we're going to see the same application. But the difference is that application is not living on a Linux box somewhere. It's living in a Docker container. And the container is being managed by Kubernetes. And so Kubernetes is now watching our container. And if something goes wrong with the container, it will create a new container. So we will get all the benefits of Kubernetes right now. And I'll talk about those now. So that's that. And then I have another one for replication, but let's just keep going with the slides now. All right, so at this point, all we did is we took our code, we containerized it, and we let Kubernetes manage it. But you might ask, like, what's so special? I mean, you're just running a container in the cloud, so what's so great about it? And nothing is great so far. But the good thing is that once you let Kubernetes manage your container, you get a lot of resiliency and redundancy features for free. So I just want to go through those right now. First, we have this wonderful thing called replica set. So when you create a deployment, it creates a replica set. And this replica set is kind of like a big brother watching your pod. For example, in this case, we are saying we have a replica set for these pods with these selectors. And then we are specifying that we want 4 replicas, right? So what replica set will do is that it will basically constantly check how many pods you have. And if you have 3, it will schedule 1. If you have 4, it won't do anything. But at some point, if one of the pods go away, it will detect that and it will create a new one. For example, in this case, we scheduled 2 pods, pod A and pod B. First, when you schedule them, you have 2 nodes to schedule things. Kubernetes will look at that and will schedule them onto separate nodes. But then let's imagine that node 2 goes away. The deployment and the replica set will detect that, and it will basically say, OK, this node went away, so I have to reschedule pod B. It will reschedule pod B to node 1. So it's watching it, and when things go wrong, it will basically reschedule things for you. So you don't have to do that yourself. If you want to do scaling, for example, you want to scale from 3 to 4, in replica set, it's so easy. So in this case, replica set has 3 pods. With one command, you just scale to 4 pods. And I have a demo of this that I might show you if I have time. But basically, scaling out is one command in Kubernetes. You might say, I don't want to do manual scaling because I don't have to think about it. I want things to be automatic. There's also auto-scaling. So what you can do is you can create something. You can deploy something called Heapster in your cluster that will collect the CPU metrics from your cluster, and it will report those numbers to replica set. And replica set will use some kind of rules to determine whether it should scale up or not. So in this case, we are saying if the CPU target is more than 50%, make sure you add more nodes so that it's less than 50%. So this way, you can auto-scale. So this is pod auto-scaling with replica set. But also in Google Cloud, with Container Engine, you can do worker node auto-scaling. So the actual nodes themselves, where the pods are running, they can be auto-scaled as well. So you can have the nodes auto-scaling and the pods auto-scaling as well. You can do Canary deployments. So let's imagine that you have your replica set running version 1 of your application, and you want to introduce a new version, but you want to make sure that that version is good. What you can do is you can create a new replica set with the second version, and this new version, it can be serviced by the same service, because the service looks at this label, right? Type equals BE. They all have type equals BE. It doesn't care that this other pod has version equals v2 because that's not relevant for service. This way you can introduce a new version, and this version will be serviced by the same service. When everything is good, you can do an update to your cluster. And then there's also rolling updates in Kubernetes. So let's imagine you have your replica set with version 1, and you want to upgrade to version 2 because you tested out in Canary deployment and everything is working. You go to your deployment, and you change your deployment image from version 1 to version 2. And once you do that and you hit save, this is what happens in Kubernetes. It first creates a replica set with version 2, and then it adds a pod. It schedules a pod with that version 2, and this will be serviced by the same service. So it creates a Canary deployment, basically. If everything is good, it will take one out here, then it will add one there, and it will just keep going like this, back and forth. And then once everything is up version 2, then we don't need this one anymore, the version 1 replica set anymore. It will take that out, and then everything will be upgraded. So this is done by just changing your deployment image from version 1 to version 2, and this happens automatically, which is nice. And there's also this notion of Liveness probes. So how do you know your application is healthy? What you can do in Kubernetes is you can create an endpoint with the path and the port, and then you can also specify some configuration. And Kubernetes will use this configuration, and it will basically ping this path and the port every 15 seconds or every 1 second, whatever you want. And it will determine whether your pod is healthy or not. If your pod is not healthy, then it will kill it, and it will create a new pod somewhere else. And then there's the readiness probe. So what if your pod is healthy, but it's not ready to serve traffic yet, because maybe it needs to get some kind of state from some other place? For those, you can create a readiness endpoint with the same kind of thing with the endpoint and the port. And Kubernetes will ping that endpoint, and when it's ready to receive traffic, it will get the traffic. But it won't kill the pod because it knows that it's not ready yet. But it's healthy, but it's not ready. So it will use that to determine whether it should serve traffic or not. And there's also a dashboard. So by default, you get a dashboard where you can look at your deployments and services and stateful sets and all that kind of stuff. So let me, I just want to show you, I have 5 more minutes, just some of these features. So let's look at the replication. So for example, here I have pods. I have some pods running, and the idea of this pod is that one. So I just want to kill this pod and see what happens. So what I'm going to do is I'm going to say kubectl delete and pass in the ID. Now replica set is watching the pod, so it's going to kind of freak out, and it will say, oh, this pod is dead now. I need to create a new one. So we'll see what happens. Now I delete, and then if I do kubectl get pods, there's a new pod with the new ID, and it's container creating. So within seconds, replica set saw that and said, OK, I need to reschedule it. And in a couple of seconds, a new pod will be created and running. So that's good. I don't have to worry about that anymore. And then another thing I want to show is scaling. So right now I have, let's see how many pods I have running. So I have 1 pod running, but I want to scale out. I want to add more pods. To do that, kubectl scale deployment and pass in my deployment ID. And then I just want to specify how many pods I want. So I'll just say replicas equals 2. And with this command, I just scaled from 1 to 2. And it happens instantly, usually. So get pods, now I have 2 pods running. If I want to do 3 pods, same thing. And then if I want to scale down, and by the way, with 3 pods, this is pending because I only have 1 machine, so I don't have enough resources, so that will be pending. But if I want to scale down, I just do replication 1, and now I scale down from 3 to 1 instantly. So scaling up and down becomes really easy. And then rolling update. I want to update the version of my app from version 1 to version 2. And how can I do that? So what I'm doing here is I'm just editing a file in my application and changing a file, some message in the file from something else to how to build ASP.NET apps on Google Cloud. So I'm just changing this file. What I need to do is I need to basically create the new DLL and then push this and create an image and then push this image to Google Cloud so I can deploy it. So that's what I'm doing here right now. But we'll skip all this because we don't have time. But what I want to show you is now I'm building my image, and then I will push it. See, I'm pushing it to Google Cloud. So that's the process, basically. You change your code, you build an image, you push it to Google Cloud, and then you can use it in Kubernetes. So now I'm pushing it, and then let's fast forward. Now I want to do an update. What I do is kubectl edit deployment, and then just pass in my deployment name. Now this will give me my deployment configuration. It's basically YAML. All I need to do is in here, there's a section called images. So right now, I am running image version 1, right? The image that I pushed is version 2. So I'm just going to change this from version 1 to version 2. And when I hit save, all the stuff that I show you about rolling update, like creating a new replica set and adding a pod and taking this one out and adding more, now that's happening. Now that's happening behind the scenes. And if I just go to the service IP, you would see that within a few seconds, I am already updated. So if I refresh this, I should see my, my text that changed to Google Cloud. But I don't have to worry about it because Kubernetes did the right thing. It did the rolling update for me automatically. All right. And I think I am almost out of time. But I just want to wrap it up with a couple more things. There is even more. So this stuff that I show you is just the basics. I just want to go through this really quickly so you know what they are. There's something called daemon sets. So the pods, they can live anywhere. There's no guarantee that a pod is going to live on a node. But if you want to make sure that a pod lives on every single node, because maybe this pod is special audit pod or something like that, you can create something called daemon set, and you get that. There's jobs. So pods live forever. If you kill a pod, you see in it a replica set creates a new one. But sometimes you have a job, you want to create some pods, do the job, and then you want the pods to go away, right? You don't want them to hang around because you don't want to pay for them. For those, you can create jobs. This way, they do the job and they go away. Stateful sets. Pods, they don't have state, right? But sometimes you want to have state in your pods because you want to run things like MySQL or Zookeeper. Or sometimes you want to be able to say, this pod starts before that pod, stuff like that. So you want to be able to order pods. For those use cases, there's stateful sets. Configuration. Configuration is really important, and we always forget about it. But in Kubernetes, you create something called config map. It's a central place to create configuration. And then when the pod starts, it will attach as a volume. So all the configuration attaches as a volume to your pods. And the last thing is secrets. So if you want to store things like passwords and stuff like that, you can create them in a central place called secrets. And then when the pod starts, just like config map, it will get attached to your pod, and your pod can use it. There's even more. I just gave you like the bare minimum of Kubernetes. If you want to know more, Kubernetes.io is the place. If you want to run on Container Engine, this is the link for it. You get $300 for free from Google Cloud, so you can easily try Kubernetes on Google Cloud if you want to. If you want the slides, this is my email. Sorry, I don't have any time for questions, but I'm going to be around, so if you have any questions, just stop by here. Thanks very much.